Hello and welcome to my channel Infowars Tech, and thank you for subscribing. We explore new topics in the areas of artificial intelligence, machine learning, cloud computing, big data. Today's topic is NumPy, or numerical Python, and this is a library for Python that allows for very high performing array calculation and scientific computing. NumPy arrays are used because they're faster and more compact than Python lists. So let's get started. You can head over to numpy.org to learn more about NumPy. This is an indispensable tool for a data scientist and must be in their toolkit. It's easy to use, very powerful. In today's video, I'll touch on some of the basic functionalities that you can do with NumPy, and I would leave it to you to explore further, and definitely recommend this tool to be part of your toolkit. This is the official website for NumPy. You can go to learn. You can start from the beginners. Some of the topics, some tutorials are available, and we can go ahead and take a look at the video today, and hopefully learn the basics of NumPy. And as I said, this is just a start to help you get into NumPy, start using it, and you will find it's a very powerful tool for array calculation and any kind of scientific computing in Python. So let's get started. I have a notebook here which I've created, and we will go through all the steps. As I said, this is not a very long video, very short. We just cover some of the at a high level, some of the topics for NumPy, and hopefully this video will create enough interest to start exploring on your own. So the first thing that you need to include is the import line here, which says import NumPy as NP. So NP is the usual abbreviation for NumPy. As you're well aware, this is a Jupyter notebook, so I can select this term and just say run, so that it runs. Let's look at the second statement. It says let's have a variable a1. It is equal to np.array. So what we are doing here is we are creating an array with some numbers. So let's go ahead and execute that. Let me go back and let's see what was in that array once we printed that. And what we're actually doing is we're accessing the third element of that row. So as is usual in computing format, the index is always starting with 0. So when I say 2, it actually means the third element of the array, which is 0, 1, and 2. Let's run that. So when I run that and I'm accessing the third element of this array, so that is 0, 1, 2, and which is number 3. We can go back and check. Let's say if we wanted to access the next number or the number after that, so maybe by changing the index to 4 should give me 0, 1, 2, 3, 4, should give me 5. Let's run that and double check. Okay, so great. So we created an array a1. Just move those elements into a1 array. This is the command to create that. As you can see, it's we are using np for NumPy, and this is one of the ways to access that array command. Let me create another array, and this one is a2. Let me just comment these out so they're not run. I'm just running this particular next command, which is a2, and as you can see, it is basically an array of arrays. So you have an array with 3 different arrays embedded inside it. So let's run that, and let's do a print to see what was created. So within that, what we're doing is within A2 we're accessing the 0, 1, 2. So it is treating all of these smaller arrays as elements. So this is 0, this is 1, and this is the third one. So what is it saying is that I'm picking up the third element, and which happens to be an array itself. Let's just make a small change. So I want to access this array 5, 6, 7, 8. So what I can do is just change that to 1, and that'll be the second array. Let me run that, and you can see that it picked up the second element of this array. Let's move on to our next command, and this just shows how I can quickly create an array with numbers ranging from 0 to 9. As you see, the total number of elements will be 10, but because it's starting from 0, the last number would be 9. So this is something that we need to keep in mind. Let me run this particular piece of code, and we got an error message. Oh, my mistake, sorry, that should be a range. That is the correct, and let me save that and rerun that. So it ran fine. Let me just confirm that it is indeed correct, and it does show that it's 10 elements comma 0, so it's rank 1, meaning it's one dimensional. So that is correct. I can certainly go back and change this to show a larger range of numbers as well. So we just printed the shape. We can also print the array itself. So we can just add that here. We can say show me 1, 2, 10, and that, and it shows the array, which is 0, 1, 2, 3 all the way up to 9. If I was to change this to let's say 11 and rerun this particular piece of code and then rerun this, you notice that it's now up to 10 items or 10 elements. So this is something to be aware of. Let's move on to the next. What we can also do, we can create numbers and have a step in between. So this command np.arange will range from 0 to 10 with steps of 1.5. Let's run that. Let's confirm that it ran okay. So as you can see, it started from 0, next number was 1.5, then 3, 4.5, so on till it reaches the limit that we set, which is 10. So as soon as it reaches 9, it can go further, and that it prints it out. So very useful way to create numbers, providing some kind of step function. Let's take another built-in command, which is all zeros. So when we run this, it will create an array with all zeros. Let's run that. Let's see what this prints out. And as you can see, we created an array with 10 elements. All of them are 0. Again, depending on a use case, you might have a requirement to print an array with all zeros, and similarly a command following that. I'm not going to run that. It's just will be the same as the zeros. Another built-in command, ones. When we run that, it'll fill up that array with all ones. There's also in matrix calculations, there's something called identity, where the diagonal is all ones. So just using the inbuilt command, you can run that and create an array, all zeros except ones that are running along the diagonal. Let's look at another one, which says when we run this, and here we're giving it the second dimension, it's going to create an array of rank 2. Let's run that and take a look how it prints out. So you can see that we created 10 rows of 2 elements each. So total of 20 elements shown in this format, 10 by 2. Let's look at how we can create random numbers and fill up our array with those numbers. So this command arr_ran, another arbitrarily chosen variable name, np.random.random 2, 4. So this will create a two-dimensional array, total of 8 elements, and the default is random values between 0 and 1.0. Let's run that. Quickly take a peek at what was printed out, and as you can see, we have 8 elements. All of them are random numbers, and they are generated between 0 and 1.0. We can run another command here which will show us the size of those elements. We expect number to be 8 because that's the total number of, but this is again a very useful utility to calculate or see the total number of elements. When we run that, we get 8, which is as expected. Now we also have the capability to take a Python list and convert it into a NumPy array. And again, one of the reasons we would do that, because NumPy arrays are faster, they're more compact, they use less memory. So I have list 1, some numbers. I will say r1 equals to np.array. That's the command that I run, and if I print this command, go back and print it, it has now converted it into a NumPy array, and we can use it for our calculation. The next one, I'm showing how we create arrange numbers using np.arange up to 20. That means it'll be 0 to 19, and we can do some calculations on the fly. And as shown in this example here, I'm creating odd numbers, or I can create even numbers just by having a conditional statement in between. So let's take a look at the odd numbers, or let's do this first. Let's run or print nums, so we know what we're looking at. The numbers, like I said, should be between 0 and 20 or 19, 0 to 19. Let's run that. So as shown here, it's up to 19 because we chose 20. Total number of elements are 20, but it starts from 0, so the last number is 19. There's something like I mentioned earlier to be kept in mind. Now let's take a look here, and I'm going to just comment this so it doesn't appear. So what we're doing is we are selecting any another variable called odd_nums, and we're saying nums are original array, and the condition is that if you take modulus 2 and there's a remainder, that means the number is odd number, and print that out. So let's run that and just go back and print that, so we know that if it was correct. And there you go. So you see it just picked up the odd numbers from that list, which matches this condition. So very again, you can see how powerful these inbuilt commands are to help us with our scientific computation. This one, what I'm doing is, if you take modulus of that number in that original array, the remainder is 0. That indicates it is an even number. And let's double check, running the print statement, and you can see it just picked up from that list from 0 to 19. It picked up only the even number. So very, very powerful way to do calculation on arrays. Here we are showing you can convert an array from one-dimensional to two-dimensional using something called the reshape. Let me just correct this. It should be arange. Here we have a 1D array with 16 elements. Let's go ahead and run that. One under 1D underscore array. Maybe it doesn't like the syntax, so let me go ahead and change that. Okay, so it's not liking that. Okay, let me just call it 1D. Let's see if that runs. Okay, let's see. So I will say 1 to indicate one-dimensional. Okay, so it was probably not liking, or it was interfering with some other command structure. I'll have to check that out. So I said, okay, some variable 1, and I created a NumPy array with 16 elements. Now let's go ahead and change that. I want to do 2, and I want to remember it was 16 elements. I want to reshape that, and I'm going to use my one-dimensional array, which is now called 1, and convert that into 4 by 4. So it will reshape it into a 4 by 4 array. So let's see if that works. Okay, that ran. I just want to print that to confirm that it ran, and it should be called 2. I just made it simpler. There was some conflict with the naming, so let's see how that runs. Okay, so you can see it was a flat 1D array, an array with rank 1. So we had 16 elements. We were able to use NumPy's reshape utility to convert that into a 4 by 4. Now because it's 16, there are other combinations that you could have, like 8 by 2 or 2 by 8, depending on your use case. You can use the same reshape, but in the parameters you will give the way you want it to be shaped. So as I provide here, I could have changed it into an 8 by 2 array, which means 8 rows 2 columns, or 2 by 8, which means 2 rows 8 columns, and so on. So depending, it's entirely dependent on your use case. Let's take a look at slicing arrays. So we have a variable called new array, and I'm creating an array with 15 elements. Let's run that. Okay, and then we are creating or slicing out a new array called newer, again using the reshape, and we are saying we want to reshape into 5 by 3, and that should work because the total number of elements are 15, and here we're doing 5 by 3, so that should work. Let's run that. Let's see what the output is. So output is as expected, 5 rows by 3 columns. Now I want to take a slice out of this. How this reads is, I say sliced, taking the just reshaped array called newer. What I'm doing is, for the row section, I'm picking up rows 1 to 3, and this syntax indicates on the column side everything less than 2 columns. So let's run that and see what the output is. And we should see that it picked up, as we indicated, rows between 1 and 3, and number of columns which are less than 2. So this is the output that we get. Again, I would this is very high level. I would strongly recommend that you have import NumPy as NP in your notebook, in your Python, or any other Python tool that you're using, and play around, explore what all you can do with NumPy. Let's quickly move ahead with I still have a few minutes to cover finding unique numbers and sorting. This section is very simple. It's just talking about we have 2 arrays. We can add those array elements using the straightforward x1 plus y1, or we can use a NumPy command np.add. Similarly, for subtract, you can do x1 minus y1, or you can do np dot subtract. And similarly for multiply and divide, perhaps I can just take one of these, and the rest are very similar to follow. So we ran that means x1 and y1 have these elements inside them. Let's just print those out so that we can see what they look like, and then we can do those operations on them. Printing out x1 and y1. So as expected, these are the elements that we moved between 24 and 34, so that is 24 to 33, 16 to 26 for y1, 16 to the one number less than 26, which is 25. Let's do dividing x1 by y1, and they'll apply to all the elements. Let's run that, and you can see that it divided element to element, x1 divided by y1. Similarly, we can also use NumPy dot divide and that's just another way to divide the array elements. Now, very interesting, finding unique numbers in an array. So we'll be faced with the use case where you have many elements in a row, and some of them we know are repeating or are duplicates. Here I have a variable name called duplicates. We have an NP array with these elements. We can see some of them are duplicates. Example 11, I see 2 11, I see 2 10s, maybe a couple of 13, and so on. So we use something called np.unique. What I'm doing is I'm running np.unique on the original array and moving the contents into unique underscore vals. So let's run that. Okay, and let's print out unique underscore vals, and what it should print are just the unique values in this array. So let's run that and see that I could see 2 10s. It's replaced that with a single 10. We have 2 11s. It's replaced that as single 11, and so on. So just imagine the possibility. You have an array with millions of elements, and we just want the unique values. That's our use case. Just running this command on that array will give you the required result. Amazing, very powerful. Let's look at sorting. So we have an array. I'm just moving the contents in some variable called numbers. So numbers gets this array with some numbers, random numbers, 56, 98, 4, 31, 16. Let's run that. Now I just want to sort those numbers. So by default, sort will do it from the smallest to the largest. Let's run that, and let's take a quick look at if they were correctly sorted. So we can see it took these numbers and sorted them accordingly. So 4 was the smallest, then 16, 31, 56, 98. Okay. Let's take another very important concept here. Let me just comment these out so we don't rerun them. And I just want to introduce to something called arg sort, which is sorting based on the array index. Very powerful, and we'll see how that works. So I have another variable called it's another array called np.array in 5.5, 3.7, some numbers. It's we're calling it prices. Let's run that. Now what we're really sorting this is on something called arg sort. So let's run that and see what the result is. So what we're getting is 1 space 0 4 2 3. Now how this actually reads is, it says that the resulting output 10423 shows that the smallest, which is 3.7, is actually in the second location of the array. So what it's printing out is the index positions. So we can see that 3.7, which in this array of prices is the smallest number. It is it's the first number here, but it says it's 1. That means in the original array is the second number. Remember, it's 0 1. So we can see in the original array this is 0 and this is 1. So that is correct. Then it's saying the second element, how it should be sorted, is in the 0 location. So 5.5 is in the 0 location, but again, as per our understanding, it's the second largest. In this location we have number 4. So if you take a look, 0 1 2 3 4, sure enough 7.5, which is in the third position, is the third largest number, and so on. So this is a very, very powerful way, arc sort, and the best use case is to be able to sort when you have multiple arrays. So an example could be, I have an item or a commodity with some pricing. I could sort without changing, so the name remains the same, and the price changes for that, right? This is similar to selecting 2 columns in an Excel worksheet and saying, okay, sort. So it says, should I include other columns, because then I want to sort so that the information is not changed. So very powerful command, and we just showed how you can read it to understand what the output indicates. Thank you very much for staying with us. This was an introduction to NumPy. By no stretch of imagination have we touched even 1% of what it is capable of. I strongly recommend that you explore this further. I showed you the website for NumPy. Please do visit this, go through some of the tutorials. It is an amazing library. Thank you very much for watching. Please stay tuned. This is our second in the series for machine learning, and look forward to sharing with you more information. Thank you very much. Take care.